So the nucleus houses the gene, which is the unit of inheritance, and also the one that controls the character that is being transmitted from the parent to the offspring. Then the next thing I want you to know is the alleles. Alleles. Genes has so many versions. So the alternative versions of gene is what we call the allele. So an individual inherits 2 copies of allele. I told you that a character, they are what? Inheritable factor. Observable inheritable factor. And I said a trait is a what? The variant of the character. When I use the example of seed color, I said yellow seed, then green seed. Now today, the allele that we said, one individual inherits 2 alleles for a character. Let's say the allele for a character is what? Stem length. The length of the stem. The stem could either be tall or short. So, for the allele for tall, so now this is the character for what? Stem length. So, stem length, tall and short. So, for each of the character, an individual inherits 2 copies of allele. The allele for tall is capital letter T. The allele for short is small letter t. Do you understand? So, that is for allele. Now, the next thing I'm going to talk about is allele. We've talked about the genes, we've talked about the alleles. Then we want to talk about the genotype, the phenotype. So let's talk about the genotype. The genotype. The genotype is the genetic individual. They are the total sum of genes that are transmitted from the parent to the offspring. Right? Now, this genotype can be divided into 2. Oh, I forgot to tell you about this allele also, which can be divided into 2. So let's quickly talk about the allele before we move to the genotype. So this allele, I said that an individual inherits 2 alleles for a character. Now, the allele can either be the same or different. They can either be the same or different. When they are different and they are inherited together, the one that expresses itself more or manifests more is the what? The dominant allele. And the dominant allele controls dominant characters. Now, look at this for example. This is the allele for a what? A tall plant. But the tall and the short, they are inherited together. But the tall plant is the dominant what? Allele because it manifests. It expresses itself more. So, the dominant allele controls the dominant character. Now, the recessive allele. The recessive allele are alleles that do not manifest. They are not allowed to manifest, especially when the dominant and the recessive are inherited together. So, the one that does not manifest is the recessive. It's not being able to express itself. So, this is the dominant allele, and the recessive allele. So, now, if they are the same, they can either be the same or different. So we are going to talk about this. So now, the next thing I want to talk about is the genotype. Genotype. What is genotype? Genotype is the genetic makeup of an individual. And it can be divided into 2. We have the homozygous, then heterozygous. So Now, you know I said that an individual inherits two alleles for a character. So when the two alleles that they inherit for a character, when the allele determining a trait is the same. Look at this. Look at this. Look at this. When the allele determining a trait is what? The same. Homo means same. Hetero means different. But when they are the same, like this one you are seeing here, the allele for tall and for short, when they are the same this way, it is what? Homozygous. But when they are different, like this one you are seeing here, it is what? Heterozygous. And this homozygous that you are seeing here, this is what? The capital letter T, capital letter T. And for the dominant, I forgot to tell you that the dominant is what? For capital. Is represented in capital letter, while the recessive is represented with what? Small letter. So capital letter T, then small letter T. Now, we've talked about the what? The homozygous. When the what? The allele determining a trait is the same. But when the allele determining a trait is different, it is what? Heterozygous. And these homozygous, they are true breeding or pure traits. Don't worry, I'll also tell you more on true breeding or pure traits when we get to the Mendelian genetics. Then, the next one is the phenotype. The phenotype. The phenotype is the total observable features inherited by an organism. This phenotype could either be behavioral, it could either be physical, then it could either be psychological. So now, we've talked about the what? The phenotype. Then, let's talk about the gametes. The gametes. Gametes are mature sex cell that takes part in sexual reproduction. They are mature sex cell. So it's a mature sex cell that takes part in sexual reproduction. Just like I said last week, I said we have the male gametes, we have the what? The female gametes. Do you understand? Now, so the next thing we are going to talk about, we are going to talk about the hybridization. Hybridization. What is hybridization? Hybridization is the crossing of parents with unlike traits. Unlike traits. When you cross parents with unlike traits, that is hybridization. So we have what we call hybrids. 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 Okay? The hybrids. So, the hybrid is a progeny or offspring that is gotten or from the crossing of two parents of unlike traits or character. Now we want to move to Mendelian genetics. Mendelian genetics. Mendelian genetics. So, if you wonder what is Mendelian genetics? This Mendelian is from someone's name, Mendel. Mendel. Mendel is the father of genetics. His name is Gregor Mendel, the Gregor Johann Mendel. Gregor Johann Mendel. That is his name. This man is the father of genetics. You know why he's the father of genetics? The reason is because the work he did then was the one that gave rise to the what? The foundation of what we call the what? Genetics. The study of what? Heredity and variation. That is why we call him the what? The father of genetics. And this man did he did wonders. You know what he did? He actually used a particular plant. It's not just anyhow plant, because he knows that if he uses just anyhow plant, he might not get what he wants. So he used a plant we call the pea plant. The pea plant. So the pea plant, the botanical name for pea plant is Pisum sativum. Pisum sativum. So that is the word, the botanical name of the plant that he used. He used pea plant. So originally, there's a reason why he used the pea plant. So we are going to talk about the pea plant because he cannot just use pea plant without a reason. One of the reasons why he used pea plant is that pea plant is self-pollinates. You may be wondering what is self-pollination. We've done pollination in SS2, but I'm going to remind you what pollination is. Pollination is the word, the transfer of what? Pollen grain from the anther to the stigma of a plant or of another plant. Now, what is pea plant has both the male and the female gamete. It has both the pistil, and the stigma. So, the pistil for the female, then the stigma for the male. So, it has both the pistil and the stigma on the same plant. So, it was able to what? Self-pollinate. That is one of the reasons why Grigomenda make use of what? The pea plant. Another reason why Grigomenda make use of pea plant is because pea plant is an annual plant. It has a short lifespan, like a year before it's. So, because of this short lifespan, it was able to use the pea plant. Then another reason why he used the pea plant is that this pea plant has it has unique characteristics, and each of these unique characteristics has contrasting traits. So he studied 7 plants. So in the pea plant, he looked at the characters of the stem length. He looked at the character stem length. He looked at the character of the seed color. He looked at the seed shape. Also, the flower color. Then also he looked at the pod color. Then the pod shape. Let's count. Is it up to 7? 1, 2, 3, 4, 5, 6. Okay, it remain 1. Okay, let's work with this. Okay, then the C shape. Okay, we talked about the C shape. So now the stem length. He said that some of the plants are tall and some are dwarf or short. So tall or short. You notice that the seed color, some are yellow, then others are green. You notice that some of the seed shape, some are round, while others are wrinkled. So you notice that the flower color, some are purple, while others are white. Then the pod color also yellow. Then some are green. Okay, the third one is the pod shape. This one too is the pod shape. You notice that some are inflated, while others are constricted. Hope you understand. So now he used the stem length. He looked at the stem length, the seed color, the seed shape, the flower color, the pod color, then the pod shape. So now in that he has looked at this, then what this Mendel used he makes sure that all the pea plant that he's using is a true breeding or a pure trait. Now I said I'm going to tell you what a pure trait or a true breeding is. A pure trait or true breeding is there are varieties that they transmit character or trait to their offspring without change in the trait from generation to generation. Meaning that if all these plants are tall and they reproduce, they will give rise to tall. If this one are short, we reproduce to give short. So from generation to generation, the trait is neither changed. So there's no change in the trait from generation to generation. Now, look at what he did. So he now used 2 methods in carrying out his experiment. He used the dihybrid, monohybrid inheritance, monohybrid inheritance. And dihybrid inheritance. You know, I've explained hybrid. I said hybrid is the offspring or progeny from a cross of two parents with what? Crossing of two parents with unlike traits or character. Now we use monohybrid inheritance and dihybrid inheritance. So we are going to start with the monohybrid inheritance. The monohybrid inheritance is what we start with today. So in the monohybrid inheritance, what he did was he planted tall plants. You notice that when he planted tall plants, all the plants were tall. Later he planted short plants. You notice that all the plants were short. Later he now did what we call cross pollination. Cross pollination. Because one of the reasons why I also use the pea plant, because he is able to control the breeding process. So he used what we call cross pollination. So he picked the tall plants, then he picked the short plant, then he now crossed them together. He picked the flowers. You know, in the flower we have the pistil and the stigma. So he picked one of the flower, he removed the stigma, and also crossed it towards another flower that has a pistil and stigma. Then he noticed that all the plants he got were all tall. So he crossed the tall plant. He crossed it with the short plant. Then he noticed that what he got was all tall plants. Now we call them the P generation. P generation or the parental generation. The reason why we call them the P generation or the parental generation, because they are the two individuals that come together to produce the offspring, because all these tall plants are the offspring and they are known as the F1 generation. F1 generation. You might be wondering what is the meaning of this F1. F1 is what? Filia. The first filia generation. Filia is from the Latin word filialis. So this filialis means of son or of daughter. So that is why we have the word F1 generation as the word, the progeny. So that is what he got. Now, for him to get the F2 generation, because this is the first set of the offspring, for him to get the second set of the offspring, he now crossed the what? He self-pollinates this all tall plant. What do you mean by self-pollination? You bring the all tall plant together with another all tall plant. Then, so for the F2 generation, so let's now do the crossing, the main crossing. Now the tall plant. So now I told you that I use pure breeding. And I said pure breeding are homozygous. So meaning that for the tall plant, we are going to have capital letter T, capital letter T. Then for the short plant, we are going to have what? Small letter T, because the tall plant is the dominant, while the short plant is the recessive. And I told you that the dominant are represented with the capital letter, then the recessive are represented with the small letter. Now, I also told you that each individual inherits 2 copies of allele for a character. That is why you are saying TT, then TT this way. Then there's a what? A sign of cross here, because this is very, very important. And for you also to know that this is what the P generation, just like the one here, the P generation. Now, in the P generation, how do we get the gamete? Because this is just the male, this is just the female. But it is the gamete that comes together for what? Fertilization. So now, also, you know I said individual inherit 2 allele. Now, a gamete inherits only 1 copy of the allele. So it's going to what? Take 1 from the male, then take 1 from the female. So we have the gamete only inherit only 1 copy of the allele. Now for the gametes. So So it's going to what? Only pick one of these, and it must be circled. Take note of this. And this one, it picks only one, then it must also be circled. Then you bring your cross down here. Now, these are the what? The gametes. Then we want to form the what? The F1 generation. Then they were crossed. They were crossed together, cross correlation. So what they got was capital letter T, small letter t. This capital letter T, small letter t that they got was the F1 generation. And it is what? Heterozygote. Because the allele controlling the gene, the allele controlling the character is different. Then this is a monohybrid. Now, what is monohybrid? Monohybrid is a cross that involves only a single character. And what was the single character we were using? We are using stem length. Stem length. The stem length maybe is either a tall or a short plant. Do you understand? So the stem length was the single character we were using for the word, the monohybrid. So monohybrid is a cross that involves only a single character. So if that single character is now a contrasting pair, like now, the single character is what? The stem length. But the trait is what? The tall plant and the what? The short plant. Please take note of this. This multiplication sign, the cross must be there. Then the gametes must always be circled. Then this is what the word F1 generation, the monohybrid, or we call it what? Heterozygote. Heterozygote. So, because I explained heterozygote here, heterozygous is the one I explained, but an individual that is heterozygous is also heterozygote. Then an individual that is homozygous is homozygote. Do you understand? Now, let's continue the crossing. So, now, as we were saying the other time, we've already gotten the first filial generation. That's the F1 generation. So how do we get the F2 generation? We should get the F2 generation by what? Self-pollinating the what? F1 generation. Meaning that we are going to cross the capital letter T, small letter t, with another capital letter T, small letter t. So let's do the crossing. Capital letter T, small letter t, capital letter T, small letter t was crossed. Now, how are the gametes formed? You know, this is an heterozygote. They will produce two gametes. Unlike the what? The pure breeding here, that they are producing only what? One gamete. But here they will produce how many gametes? Two gametes. Meaning that we have what? The capital letter T, it must be in circle, please. Then the small letter t, then the capital letter T, then the small letter t. Now, we want to do the crossing. Now, the first thing is for you to do is what? To cross the T here to the T, meaning that this T must cross this one and this one. This small T also must also cross this one and this one. Now, let's do the crossing. Okay? So, capital letter T, capital letter T. Again, this one must also cross this one. Capital letter T, small letter t. Now, this one must also cross this one. So it is what? Capital letter T, small letter t. Then this one must also cross this one. Then we have small letter t, small letter t. Can you see that the F1 generation is different from the what? F2 generation. Because the F1 generation, we got only one heterozygote, and which is a what? Monohybrid. So now this is a what? A monohybrid cross. So what is a monohybrid cross? A monohybrid cross is a cross between monohybrids. This monohybrid or the F1 heterozygote. That is a what? A monohybrid cross. But a monohybrid is a cross that what involves a single character. But a monohybrid cross is a cross between what? Monohybrid. The first monohybrid here, then the second monohybrid here. So these are the what? The second filial generation. So we have what we call, so now we have the top plant. Now, you know this is what? Homozygous. This is what? Heterozygous. Heterozygous. Homozygous, right? Meaning this one is what? Homozygous tall. This one is what? Heterozygous tall. If you remember when I was explaining heterozygote, I was explaining the dominant and recessive. That I said the one that manifests itself is the what? The dominant. So because there is already a dominant, so meaning that this one too is what? Tall. This one. But this one is what? Homozygous short. Meaning that we have how many tall now? We have 3 tall and 1 short. Now, what is now the phenotypic and genotypic ratio? You know, I said the genetics is the what? The genotype is the genetic makeup of an organism. Then the phenotype, the physical, is it not the physical, the behavioral? Now you can see from here, you can see we have tall plant, short plant. So the phenotype is what? The observable features we can see. The physical features we can see what? The tall and the short. Meaning that the what? The phenotypic ratio is what? The phenotypic ratio is 3:1. But the genotypic ratio, we can also say that the genotypic ratio is the what? The number of what? Pair of allele. How many pair of allele do we have here? We have 1 homozygous pair. 1 homozygous pair, another one, 1 homozygous pair for tall, but 2 heterozygous pair, then 1 homozygous recessive pair. Meaning now that we have what? 1 for representing the what? Homozygous pair for tall. Then we have 2 what? Heterozygous. So 1:2, then ratio 1. Do you understand? So this is the what? The genotypic ratio. Genotypic ratio. But this is the what? The phenotypic pair of allele. But this one is what? Homozygous allele, heterozygous allele, then homozygous recessive. Do you understand? Now, this what Mendel did was now what led to the Mendel first law of genetics. So the Mendel first law of genetics is the law of segregation of genes. Law of segregation of genes. Law of, okay, let me write it in the way you will see it well. Okay. You understood all what I've been saying since? Okay. Now, Mendel law. Mendel first law. Which is the what? The law of segregation. Segregation of genes. So that is what the Mendel first law. So the law of segregation of genes states that what? A gamete inherits only 1 copy of the allele. Only 1 copy of the allele, and it is what? Inherited independently. That is what the law of segregation of gene. So that's the first law of genetics. Now, we are going to talk about the second law of genetics before we round up the class. So, the second law of genetics, okay? Oh. So, in the second law of genetics, before we move to the second law of genetics, we need to talk about what led to the second law of genetics. So, you know, I said he used 2 methods, the monohybrid inheritance and the dihybrid inheritance. Now, we've already talked about the monohybrid inheritance, and we talked about how it led to the law of segregation of genes. So, the second one is what? The hybrid Inheritance. Inheritance. So what is this dihybrid inheritance? So now, for us to know the dihybrid inheritance is two or more character. But in this dihybrid is what? Two character. So it makes use of what? One of the character, two characters here. So it makes use of what? Seed column. Seed column. And it also made use of what? Seed shape. But you know in monotypes, it made use of only one character, which is what? Stem length. But here it made use of two characters, which are what? Seed color, then seed shape. Now, let's know the dominant, then the recessive. So, the seed color he used was what? Yellow seed, yellow, then green seed. Then the seed shape was round and what? Wrinkled. If you remember when I was listing the what? The characters used. Round and wrinkled. So this seed color was represented with capital letter Y because it's what? The dominant. Then the green, which is the recessive, is represented with what? Small letter Y. Then this seed shape, the round, is represented with what? Capital letter R. Then wrinkled with what? Small letter R. So it made use of two characters. The seed color, then the seed shape. Now, I know this, I said it makes use of pure breeding plant. So during the first crossing, you crossed, you crossed so you use the seed shape and the seed color. Now round yellow, then wrinkled green. Those are the two he used. Then wrinkled green, and they are all pure breeding. Remember what I talked about pure breeding, that they are what? Homozygous. Meaning that what? And now, if you see this thing now, you notice that we have two characters. And I said, the two characters, I said each individual inherits two alleles for a what? A character. Meaning this what? This round will be what? Capital letter R, capital letter R. This yellow will be what? Capital letter Y, capital letter Y. Now, wrinkled will be what? Small letter R, then small letter Y, small letter Y. Then, there's supposed to be a cross here. Now, we want to what? This is what? The P generation. P, let's write this. Because if we don't write this, we are losing mark already. The P generation. So now, I said the gamete inherits only one copy of the allele. Now, meaning that the gamete will inherit only one here, then it will inherit only one here. One here, one here. Now, and all of them are inherited together, meaning that we have what? Capital letter RY. So, this is the gamete. Then, small letter RY. This is also the gamete. Then, this is what? The gametes. Then, they are now what? Crossed together to give us what? Capital letter R. Capital letter R, small letter R, then capital letter Y. Okay, there's a mistake here, it's capital letter here, because it's capital letter, then the small y. So this is what? The F1 generation. It is what? Heterozygous. But now it is what? Dihybrid. This one, I said that one is monohybrid, but this one is what? Dihybrid. Dihybrid. Or double heterozygous. Double heterozygous or dihybrid. So what is now dihybrid? Dihybrid is the crossing that involves two characters. Crossing that involves two characters. Now, that is what dihybrid. For dihybrid crossing, we want to do the dihybrid crossing. The hybrid crossing, so you see the hybrid crossing because we did the monohybrid crossing in that place. Now I want to do the hybrid crossing. Sorry. Okay. Don't worry, I won't take your time. Okay. So now, the dihybrid crossing means that for us to get the dihybrid crossing, we have to what? Self-pollinate this dihybrid. How do we self-pollinate? You know that is what? Just crossing of this one and also something of this exactly. So we are going to cross this together, meaning we are going to have capital letter R, then small letter r, capital letter Y, small letter y, then capital letter R, small letter r, then capital letter Y, small letter y. So it is what? Cross together. But Mendel now said something. He said that each of these allele can what? Can either be what? Can either be crossed with any of the what? Other allele, meaning that the what? They are inherited independently. That they do not need to, they don't stay together. Meaning that the what? This R can be crossed with what? Yellow, and also can be crossed with what? White. That this R can be crossed with what? Yellow, and can also be crossed with what? Green. So meaning that this what? The genes are, they can either stay separately, and they can now be crossed with any. So when he was forming his garment, he said R, meaning the round, can stay with either the what? Round yellow, then it can also say with what? The round green. Capital letter R. So this is one allele. Then capital letter R, small letter r. Small letter r, capital letter R. Let me put this so that you will see that there's difference. Then that is how he did it. Then remains one. See, capital letter Y, R, capital letter Y. Capital letter R, then small letter Y. Then small letter R, small letter, then small letter R, capital letter what? Y. Meaning that what? Each of them can be what? Can match with any of the what? The other gene. So also like this one is because they are having the same for the man and also the same for the woman. So now R, capital letter Y, then R, capital letter small letter y, then R, capital letter Y, then R. So now he now do the crossing here, but the crossing here will not be what? Visible if we don't use the Punnett square. So he used the Punnett square in getting the hybrid crossing. So we need a bigger space to do the hybrid crossing. So let's use this place for us to do the Punnett table. So the Punnett table is drawn. We're going to draw it now. The Punnett table. Okay. Punnett table. Now, the male and also the female. So the male should be here, then the female should be arranged here. So in the arrangement, we are going to write capital letter Y-R, then capital letter Y, then capital letter R, small letter Y, then small letter R, capital letter Y, then small letter R, okay, then small letter Y. So that's how we are going to arrange the female here as well. Capital letter R, this, then this, this, okay, it's capital letter, then this. Now we need to what? We need to cross it together. This is crossing. So we have the what? The male, then the female garment. So in crossing it, we have capital letter R, capital letter Y, capital letter R. We are crossing it together this way. Then capital letter Y. This one also is crossed with this. Capital letter R, small letter Y, then capital letter R, capital letter Y. Now, this one also is crossed. We have capital letter small letter R, capital letter Y, then capital letter R, capital letter Y. This as well is crossed. Small letter Y, R, small letter Y, then capital letter R, capital letter Y. Okay. Now, the same way we are capital letter R, capital letter Y, then capital letter R, small letter Y, then this also capital letter R, small letter Y, then capital letter R, small letter Y. Hope I'm getting it, okay? Small letter R, capital letter Y, then capital letter R, small letter Y. Also, we have the what? Small letter Y, R, small letter Y, then the capital letter R, capital letter Y. So that's how we are going to be doing the Punnett square. So this as well. This one, capital letter R, small letter Y, then small letter R, okay, capital letter Y, okay, then this as well, then, okay, it's capital letter, and small letter R, capital letter Y, so capital letter R, small letter Y, then capital letter R, capital letter Y, then this one is capital letter R, small letter, sorry, small letter R, small letter Y, then small letter R, small letter Y. Also, this, sorry. Okay, capital letter R, capital letter Y, then small letter R, small letter Y, then capital letter R, small letter Y, then small letter R, small letter Y. Okay, then small letter R, capital letter Y, then small letter R, small letter Y, then small letter R, small letter Y, small letter R, small letter. So now this is a Punnett square. You can see it took a lot of time before we finish it, but it's very easier if you understand it. Now, if you look at this, most of it looks different. This one is capital letter R, Y, capital letter R, and capital. Now, for you to know that this one is what? This one is what? All round and yellow. This is because this R is round and is dominant. This Y also is round, is yellow and is what? Dominant. Also, we have what? Capital letter R, then capital letter Y, meaning this one is what? Round yellow. Meaning that we have what? One round yellow here. So let's put it like this so that we know. We have one round yellow here. Let's look at this one too. We have a dominant character here. Capital letter R, then capital letter Y. This is the what? The second round yellow. Look at this also. We have capital letter R. Yes. Then we have capital letter Y. Meaning we also have a dominant character here. Because the round is dominant, the yellow also is what? Dominant. So we have what? The third round yellow. Let's look at this one also. So we have round yellow also here. Capital letter R and Y, which is dominant, also is present here. Meaning we have the what? The fourth round yellow. Hope you are getting this.